this computer. Cool. So HTTP server 1, I git cloned it. I open it up in my current window, and I've got open up the server.py file, and I have all this information, so I don't even know what this is right now. I'm going to read through some of the document or the README. So for this challenge, we're going to build an HTTP server using Python. We'll use a lot of what we've learned so far, but some of the techniques we utilize to accomplish this will be entirely new, like sockets and and HTTP headers and all that. So that's like the new portion. But the main things we want to focus on is, single responsibility code, reinforce OOP, object-oriented programming, and just learn about HTTP concepts. So you rarely, if ever, are going to actually have to create a server on your own in your job. You'll pretty much never have to do that. I can't imagine anyone having to do that in their job. But this just kind of breaks it down, building your own server, understanding, HTTP headers and kind of what actually gets sent over via the HTTP protocol. So let's just look through release 0. Hello world, HTTP server, speak over networking protocol, TCP IP. It turns HTTP requests and responses aren't sent over to the web as a single blob of text. Instead, they're transferred over as a smaller packets and reassembled in their final destination. Luckily for us, we don't have to learn TCP IP from scratch to write an HTTP server. Python already ships with an built-in library called socket right here. And the documentation isn't that great. It's just like a lot of reading, but which we will use to build our server. So inside of our server py file, we see the following code where we import socket. We are given this socket.socket. We don't really have to really know what this is. This is just given to us. The main thing here is the server.bind. This is where we want to actually bind what port number and like the location of where we're going to be hosting our actual web server. And it's currently, we pass in a tuple, which the location, which our local machine is literally called the localhost. So you can pass in a localhost and then the port number. And the port number is just, it allows external devices or some external point to access your machine, essentially, like hard drives, all other stuff like that, as well as like a web server. We print, waiting for connection. We listen for incoming requests, and then we are able to accept incoming requests with this server.accept, which we're given client connection, which like parses out into two variables, client connection and client address. We're not doing anything with client address at the moment and throughout this the challenge. So we put a little underscore in front of it because we know we want to let the other developers know that, hey, we have this variable that client address comes from this server.accept, but we're not going to be using it. Then we're going to print new connection received. So when we actually get a connection, or when somebody actually a request comes in, we should see this, I believe. And then once the request's data is no longer coming into our server, we're going to close the connection. So pretty much just walk through this right here. And then our program is going to wait until it receives a connection. After it receives one, it will print new connection received, and then it's going to immediately close the connection. So to get started, let's actually run our server in the terminal. So here's all of that. And to run our server, we literally just Python server.py. There we go. We have the waiting for connection. So now the server's spun up and it's running, and now it's just listening. So it's literally just listening for things to connect to the web server or like pass data into the web server. And so it's just listening right now. All right. So as a client, we want to be able to make a request to the server listening on port 9292. We have many choices on how to make requests to the server. We have a Chrome, which is we can literally just go to localhost 9292, but we're not going to do that right yet. Where are we at? We can use Postman, which is a software that allows us to make all kinds of different requests, put like get requests, put requests, just all kinds of requests. I actually think I have it. I haven't used it in a long time. Postman. Or our terminal or Mac comes with a built-in curl command that enables us to get like requests via the command line. And that's probably what we're going to use. It's easiest to use. So let's do that. So let's start with curl, open a separate command line window and run this following curl followed by http//localhost9292. So if I go to here, I'm in this terminal, but I have to open up another terminal. I can either create one here by clicking that, or I like to actually just use a totally separate terminal, just kind of easier that way for me. So I can write, I'm just gonna copy and paste this, curl 9292. There we go. And I'm gonna print that, or click that. It says curl, receive failure, connection reset by peer. Over here in my actual server, it says waiting for connection, new connection received. And then it just exited the application. It says the connection reset by peer, that's fine. Let's actually look at what happened. We came in here, received an actual connection. So it was listening to it. We received a connection, it printed new connection received, and then it just immediately closed the connection. Does anybody have any questions about that process?
Is it common for multiple requests to be sent in via like one click or one command type things? For instance, we'd send in something and it was almost like there was a time delay. So like when we get a little bit further on, it wouldn't quite display right. And then we also started, basically I noticed we're just doing one refresh would actually send like 2 requests through. I just wasn't sure if that's common.
Like once we get down to the HTTP protocol and you're like clicking refresh in the browser and it's like sending 2 requests at the same time.
Yeah, because I was able to kind of figure out roughly, the first request is me actually clicking the refresh, and then the second one is sent in automatic, asking for the fave icon. Yeah, so that's, and somebody, the other guy, he told me, my partner, he told me that's what the little picture, the icon, so if you look at your website,
yep,
you get the little icons up there.
That little right here. So
what was happening was the connection would close before it got to that point, and then especially when it came to rendering, so I had to have a delay, just so that way enough time would pass, for the request to also render the hello world on the website. But if I didn't have that, just a code in there to give me a time delay, then the page wouldn't even display. It would just say there's a connection error.
Yeah. I remember running into that like 6 or 7 months ago when I was first doing this, but I never ran it. I haven't run into the issue of it not being able to come through, but I would still see the favicon come in the server side, but it didn't like interrupt anything. So I wonder, I don't know. And was it only when you went through to like the hello world and not to the /time?
It would actually happen with both.
Oh, okay. All right, interesting.
Yeah, so anytime it was trying to send a second request through, so I almost kind of, I followed another tutorial somewhere else, and it kind of actually covered part of one of the other releases in here of extracting out the data and the receiving, and that just created enough of a time delay to actually allow the page to post properly or display properly. So it's like the request got sent, the first one got sent, and then it closed, and the second one got denied as far as the browser is concerned. And then because it got denied, it didn't even bother to display anything. It just said, hey, there's an error.
Yeah, I'm not quite sure specifically like what causes that, because I think when I did it like the first time, it only happened when I went to the backslash and not like the backslash time. So, but yeah, we'll go ahead, Chris.
I just have a question for Daniel. If you give it another shot, or maybe you know off the top of your head, when you start your server and you send that first request, see if you can keep spamming the request, and if they will keep, if it keeps refreshing, and then stop for like 5 seconds or 10 seconds or something. Just stop completely and then try to send that next request, and then see if it freezes after you pause for like X amount of seconds. If that happens, then I think I know what it is.
Okay. I'll probably bring it up further, I guess, once we get to the next part of the release, because I was able to print out what stuff that was happening. I could print out the request and print out what was received. But yeah, every single time I did one refresh, there would actually be 2 requests that would process, and I could see both requests, and then that would be it.
The request thing, that second subsequent request is actually coming from your browser, Chrome and Firefox, and I had a lot of popular browsers do the favicon thing. If it 404s, every single request you send, it will try to re-request the favicon again. And I had the same problem.
I remember that now. There's like some asynchronous action that goes on that it's waiting to actually finish the request. So then it, like, when you connect again, it sends the favicon or something like that.
I can show you what you can place inside like your template, or depending on which version of the project you're working on right now, but I can show you what you can place in there so that Chrome or Firefox will like cache it so it doesn't request it again. It'll cache like some blank data basically for the favicon, and then it won't even try to bug you about it anymore.
Let's move on. Let's keep going. So we make the GET request. After you run the code, the server should accept the request, print the new connection received, and then exit. So we just did that. Where'd it go? Right here, new connection received, and then it just immediately closed, and it closed the application. So let's refactor to do something more interesting. Let's respond to every request with hello world. To do this, we'll use a client connection variable to send receive data. Client connection is a socket object. Read through the documentation to find some methods that can send data. Then modify the code in server PY so that each time the client makes an HTTP GET request, our server, they get hello world as a response. All right, so I'm going to click on this, see what it is. I'm going to look at send. We have some send message. So I'm looking here. We have the send. Interesting. I don't know what this S1 is, so don't know what that is, but I'm going to keep going. Here's the socket.send. Client data to the socket. All right, I'm just kind of reading through. We have send all, send to. It says bytes. I don't know what that means, but let's go. All right, so let's see if that dot send works. All right, where am I at? All right, let's go. Whoop. So new connection. So it says, we'll use the client connection variable to send and receive data. So we'll do client connection dot send. Let's go hello world. So client connection dot send hello world. That looks right. Yep, let's try that. So let's run that again. Open that up, open the server. So the server's running, it's waiting for a connection. Now if I come up here, run through localhost 9292. All right, it says receive failure up here, and come down here in the actual server. So it says file server.py line 10, which is here. It says type error, a bytes-like object is required, not a string. So I don't know what that means, So I'm passing in a string here, but it looks like it needs a bytes-like object. I have no idea what that means. Let's come into here. I'm just going to open up some Stack Overflows. This code. So I type error byte-size object. So that's kind of like the error I have. And it says you'd like to have to use bytes object instead of a. That's not really it. All right, it says you can use the word, or you can use encode by using .encode. All right, so I've got this hello world that kind of looks like mine. I'm going to use .encode. And what is encode? What does encode actually do? So let's try this one more time. Come up here. All right, does it show up? So it's nothing broke, waiting for connection, new connection received. And we can see it says hello world right there. So in order to send data over to our server, we need to essentially encode our string, transfer them into bytes instead of like having it be a string. And I think you can also, based off of the documentation, it looked like you can put a B in front of it. Does that change it to bytes as well? Let's look at that. I'm going to just copy this line down here and put a B in front of it. I want to see if this works as well. Waiting for connection up here, curl. So it looks like that works as well. So putting a B in front of your string turns it into bytes as well. But I'll just keep it as encode right now because I know that's working. And yeah, does anybody have any questions?
Does encode take any parameters? Because I saw something where you could turn it to different types, and maybe that's me typecasting. Because instead of doing a B and it was a B string instead of F string, and instead of using a B string, I used bytes, and then as a function to turn the string into a byte. And that we take the string as a first argument. The second argument is the, are you trying to convert it to ASCII, or are you trying to convert it over to UTF-8? Yeah. So does encode, does that automatically do UTF-8 by default, or is there any parameters?
Python encode, I think I don't know what the default is, honestly. So it looks like encoding defaults to UTF-8. Yeah. So there you go. And that's what we kind of want, because when we actually have to decode some requests, or yeah, we're gonna have to actually end up decoding as well once we get down into like part 2 or something like that of the assessment or of the challenge. But there's other ways you can do it, because I know I've done byte, like I've used the bytes method as well before, but I just know encode works. So, all right. So you've successfully completed your first request cycle. This cycle is what the whole internet is built on. It can be hard to grasp. All right. Same concept of like what we're doing now on our current laptop is the same essentially thing as somebody in California accessing my server right now. So keep our server running. Right now, our server quits after sending a response. We want to keep the server running to handle multiple requests. We can solve this by having a while loop to keep the server running. Modify your code and server so that after the server responds, it starts listening again for new requests. All right, so what do we actually need in our while loop? So we can bind it there, waiting for connection, print new connection. Did I delete the code connection close? Yeah, I think I did. So everything in here, while we can just do while true, I think everything should still work. Let's just see. All right, see if this works. Clear. All right, waiting for connection. Come up here. Hello world, waiting for connection. New connection received, waiting for connection. Cool. I could just quit, and there we go. All right. Let's go back to the dot. All right. So now comes like the hard part. HTTP protocol. So right now we're responding with a simple string. Let's modify our code to respond with a standard HTTP response. In order for response to show up in Chrome, we have to format it to include at least the following. Let's actually see if this works in Chrome as it is. So I'm going to run up the server. All right. Now I'm going to come to a new tab and go to localhost 9292. And this page isn't working. So it looks like it's just must have done multiple requests or something like that. Interesting.
Yeah, I can tell you how to do the thing that I did to allow it to actually display on the page if you want.
Let's just walk through this, and then afterwards we can walk through. So you got it to display on the page without having to actually. That's interesting. All right. So HTTP protocol, right now we're responding with a simple string. Let's modify with a standard HTTP response. Let's open it up here. Protocol web. All right. So pretty much, if you look, I like to open up the console. If you look at your network, is it application? Oh man, there's a lot of junk up here. Let's just go here. Network. And you can see, so if you go to your Chrome developer tools and you click network and you click on any network requests that are coming through, these are all the network requests that are coming through. You can see the headers. We got request URL, request method, status code, remote address. And we also have response headers, but nothing. So this is what you can kind of see what's actually coming through in the headers. So if you actually read through the documentation of this, you need, where is it? Is there anything, does it give us like the minimum? So we need get, so this is headers, connection, keep alive. All right, this is the type of data, the type of request that can come in as far as like text or anything like that. All right, so if you read through this, but basically you need the HTTP protocol, which is HTTP and the status code and reason phrase, some content type, what type of content you're sending back, the length of the content, followed by a blank line, so a space in between those, and then the body of the response. So in this case, this is literally just all of our HTML, which is in the body. And you need a carriage return between each and every one. A forward or /R/N just literally just says, go to the new line at the very beginning. So here's a hint of what a string representation of the HTTP protocol response should look like. So what we need to do is essentially modify our code to have a hello world as well as all this HTTP protocol. So what we can do is, where are we going? So HTTP protocol, we need a status code, status reason, which is status code. What's the status code for like a get, like a good get request? Is it 200 or?
Yeah, 200. Okay.
All right. So it's status code 200. Where'd it go? All right. So it would be like HTTP. So I'm actually going to just copy this so I don't have to keep going back and forth. So, so I'm looking for hello world. So I'm going to copy this over here because this is kind of what we actually want to send through, as well as we want a string representation of, I think, this part. So I'm just going to put like HTTP response. I'm just going to assign it to a string right now. And so it's like HTTP, it's 200, is it slash OK?
Space. No
Space
slash.
OK. Oh, yeah. Space OK, followed by a carriage return, followed by, was it content type? And we could do text slash HTML, carriage return, content length, followed by, it looks like I'm going to have an F string because I have to put the length of the content that we're returning. So I'm trying to think. So I want to try to keep with single responsibility code. So I think I'm just going to actually create a method up here called HTTP. I'm going to build the HTTP response. And it doesn't take in anything. It's going to take, I'm going to say HTML equals this. And then it's going to, I can do like HTTP response F string content length will be the length of the HTML, and then what else is there? A blank line and the body of the response. All right, so a blank line, carriage return, and another carriage return because we need a blank line. This first one just takes it to one line underneath content length, and then we need an actual space in between content length and the body. Followed by HTML, I can just return HTTP response. And then I can actually just invoke this method. Does that make sense? So what I'm doing, I'm literally building the HTTP response with our headers, which is all right here, as well as the actual body, which is pretty much everything in our HTML. All right, let's see if this works. I'm going to delete this. All right, so if this works correctly, if I clear here, all right, I've got the string of HTML body with hello world. I'm going to actually make this, let's see. And let's see if I refresh this, there we go. We have our hello world up here. And let's make this a little bit bigger instead of p tags. Let's do h1. And I can clear, start the server again, and refresh, and there's our hello world. All right. So we have that. Once the output from the curl looks correct, try making the request with the browser and ensure the browser displays hello world before moving forward, which we have done right here. Great. If you want to inspect the page, you can actually see our hello world right here. So we're currently ignoring the request. We want our server to be able to respond in different ways depending on what kind of request the client sends. Start by checking the socket documentation to find a method that will allow you to receive data from the client. All right. I'm going to just type in res receive message. All right. So we have socket.receive. So receives data from a socket. This return value is a byte-select object again. Okay, let's see this. Oh, something just happened. I'm gonna type Python example. Here's all of the Python documentation. And here's a socket programming and Python guide. This is actually a really good resource. If you found it, it probably made your life a lot easier. Socket, so I'm just gonna type in recv. All right, cool. So let's see this work. So sockets in Python has data as bytes. You'll have to use decode UTF-8 to convert those bytes to strings. All right. So we can use the recv, and in that documentation, we have the connection connection received. So we have connection send, and we can do client connection.recv. And based off of that documentation, is 1024. Does anybody know what 1024 means?
It's 1 kilobyte at a time.
Yeah. So it allows, so if we didn't pass anything in, it would only probably show like the very first part of the string of what you're actually trying to respond with, or yeah, it'd only show you like the very first part of like not the HTML, the actual string. But if you look 1024, so the buff size argument 1024 used above is the maximum amount of data to be received at once. It doesn't mean that we'll return 1 kilobyte. It just means that's the maximum it can receive. So that's what we have to pass in there. All right.
Does that mean that that's the total amount of data completely, or it just breaks it into chunks of that size, packets of that size?
So that's just the maximum size it can receive. It doesn't necessarily, I don't know if it breaks apart. I'm not 100% sure whether or not if it breaks it out into different packets or anything like that. Does anybody know? I think it's just like the maximum amount that can come in through the server at one time.
Okay, so if the server was socket was trying to send back 2,000, it would fail.
Yes, correct.
Well, I think it's a buffer. Yeah, it's a buffer size, so it's just going to get the first 1K.
Yep.
You have to do it again to get the next until you're done.
So you have to set up a separate thing to get the second chunk.
Well, like a while condition, you know.
Okay.
Otherwise, if you didn't chunk it like that, then if somebody was sending you a 100 megabyte or a gigabyte file, then you're going to be tied up the entire time, and that's asking for trouble too.
Okay, so we don't have to necessarily keep our responses below 1024 there. Just got to realize it'll be buffered that way.
Yeah, I think if you try to do more than that inside of where is it? If you enter more than that, it'll actually something will break in your server. Like, I don't know if it'll, I think your connection will break or something like that.
Yeah, in the docs it says it can be any power of 2. So you could even they show right in there you do like 4096, I think, or 4098.
Oh, okay. Huh. So let's move and whoop. So, whoop. Where's my stuff again? So we have this client connection received. We can actually assign this to a variable. Let's call it request data. And that's actually, I'm gonna import IPDB. This is that debugging library. Now if I do IPDB.set trace, when I execute this, I want to inspect. Oh, waiting for connection. If I refresh up here, if I come down right here, I want to inspect what this request data looks like. Request. So there is everything right now. It's a byte size, so it looks like it has all this headers, where it's coming from, the connection, keep alive, all this stuff. It's pretty much not very useful to me at the moment. I don't necessarily know what the sec fetch site means or anything like that. Cool. But now I want to be able to, so right now it's a byte. And in our documentation, or in the README, it says, so it receives data as bytes. Now we'll have to use decode UTF-8 to convert those bytes to a string. So if I literally just do .decode UTF-8, and now it pretty much looks the same, but no, it's no longer a byte, it's actually a string. So I can do like type request data dot decode UTF-8, and it should be a type string. Oh, spelled decode wrong. So class string, whereas if I went all the way up here, put type class bytes. So I can actually copy this and put it up here. So we have request data. I'm gonna actually exit out of this, clear it. Don't need that anymore. Let's see, oh man. Actually, I wanted to see that one more time. Waiting for connection. Just want to show you something. So if I refresh it, and I do request data, so I get the get request, and it goes to the backslash, or the first /, and that's based off of the whatever is right here, which is, if you remember from a couple of days ago, or was it yesterday? Yeah, it must have been yesterday. It's called, is it the URI? Is everything after the localhost port number? So that's actually like URL, or like what we call the URI. So if I were to go to clear, exit, clear, let's run that one more time, server, and I go to / something else. And if I type request data, it can go to / something else. So what we actually want to do is extract that specific. So now we know how to code now. So now we can extract this something else, this URI, and have like a conditional statement and display certain things on the web page. Like if it just goes to backslash, display hello world. If it goes to backslash, or I'm sorry, / something else, display something else. If it goes to / time, display the time. And that's what we're going to get to. So exit there. So we have this entire big string. So we can actually do request. So we have the request data. We can request the URI, which we want to actually extract this from this gigantic string. So we can actually do request data. How do we do this? Request data, we have to split this. Request data dot split. And then let's put another IP set trace in there. Run this again. Waiting for connection. I'm going to refresh this page. Uh-oh, what happened? Oh, I forgot to decode it, didn't I? Request data dot decode UTF-8. Maybe that should work. So clear it. Oh, didn't work again. It's already in use. So what happens if this port number is already still in use, which takes a while to shut down. I'm gonna refresh it. Go to a different port number. I'm going to 9291 now. Waiting for connection. Change my port number here. Oh, I'm not saving it.
All right, that's the problem we were having, Tom. Do you still have connection close at the bottom of your while loop?
Yep.
And it's still doing it.
Yeah.
That's the problem we're trying to solve.
It just takes a little while for it to close.
Yeah, I think another alternative, and that's what I was going to ask, was if you look at the line 28 there, that's for the connection to the client that's closed. And the client connection is a socket. But if you scroll up at the very beginning, the server is a socket too. So we never actually close that socket out. That's what I was going to ask, is like, does it automatically get closed at the end of the program, or does, so I'm assuming that each socket you open, you need to close, which is why we closed it at the bottom, but we never actually closed the server socket. So that's one thing I was just kind of curious about.
Yeah. I mean, you could throw the connection dot shutdown. I mean, it would still work. But I think in the documentation, when it talks about disconnecting, since a lot of socket libraries, the close method and a lot of socket libraries automatically shut down everything. So it's not 100% necessary to have the shutdown method. But if you have it there, and if it works, yeah. I mean, that's generally the order. It's in the documentation. It says like, hey, do the shutdown first and then close the connection. But it also says like it's not 100% necessary. So I'm in the server. I'm at the set trace. I'm gonna inspect this request URI. So here we go. I've got an array of all like the headers of everything. And it looks like the array. So if I request URI at index 1 is the actual URI. So up here I can do grab that URI, not 1. And now I can actually start doing stuff with this. So I'm gonna exit here. So if I print this, so I've got this URI, so I can say like if request URI equals / do something else, you know, do something else. And I'm gonna move this stuff up here. Is that where all that was at? Oh no, that was down here. Connection closed. So I've got the URI. Now I can actually send stuff back to the server or to the client. So let's come here. Whoop, not that one. So here we just parse through a request. So based off the URI, we want to respond differently. So if the URI is just a /, just respond with hello world. If the URI is /time, respond with the current time and insert the current time here. All right, so we're at that point. So how do we send data? Build HTTP response. So here's where we actually send it. So I can move this all the way down here. And let's just test that one right now. So clear. Uh-oh. There we go. Clear again. Waiting for connection. If I come over here, if I just go to the /, I get the hello world. Great. If I go to back /time, I don't get anything because we're not sending anything back. So with that, I can build another HTTP response for that other request. So build HTTP time response. And this takes in the current time. So I can say current time equals, I have to import date time, or is it from date time, import date time? Time, import date time. And now I want to, I don't know how that date time thing works. So Python date time. I'm gonna close this out. Date time, is it now? Datetime.now. There we go. So in here I can do datetime.now, current time, and this should be an F string as well. And everything looks about the same. So down here, I can now, instead of passing in the old basic HTTP response, I can pass in the build HTTP time response. Let's see if this works. Python server, waiting for connection. Let's go to home first, hello world. I go to /time. There we go. That looks really ugly though. How did I do that? How do I change that to look somewhat decent? Is there a date time?
The date time object has a method that will let you format it into a string. I think
So,
it's
string.
I don't remember.
How to format Python date time. String time. So
It's strf time as a,
all right.
yeah, it's that one.
So I'm just gonna use this one. Well, I'll use this one. So instead of dot stringify time, so I can clear that, run the server, see if I refresh it. Yeah, that's a little bit better looking. All right, so we got that done. Now we're on to release 3. At this point, we're not doing a great job of separating our concerns, following the single responsibility principle because our server does more than it should. It's receiving requests, parsing the requests, and sending a response. Let's make our code follow single responsibility. Every piece of code should do one thing. So it says first, let's create a request.py file, and I'm going to copy and paste this request class in there. So I'm going to clear, I'm going to list everything out. We have our server file and our README, but now we want to touch request.py, a code request.py. I'm going to break that off into that, split the screen, and copy that in here. All right, so let's figure out what's actually going on. So the request class takes in one parameter called request text, and the request text receives, decodes it, and splits it at the carriage return. Interesting. So it does all that, which we're doing, I think, all like right here. That entire thing is what's going on right here. And then it's passing it into a parse request method, instance method, which comes down here, takes in the decoded request text, which is all of that, and then it does something to it. Parse request, interesting. So then we can, I'm sure we can actually just print it out here. Whoop. Print decoded request text, which should be, yeah.
List.
It'll be a list, right? Because it's splitting at the carriage return. Okay. So it takes some time to figure out and finish fleshing out the parse request method. In the end, you want to return a dictionary that contains all the headers from the HTTP request. Okay. Seems like a pain in the ass. All right. Curl. Cool. So what do I want to do? Let's see. So we need to actually create a request instance in our server.py file. So the first thing I'm gonna have to do is import, or from request, import request. And what I'm passing in here is just the request text, which is the client connection. The client connection does all of this stuff. All right. So if I needed to do, I can do request. Yeah. Do client request equals request client connection. I don't need this anymore. I just want to print out this decoding. So when I run this, it's going to come in here, do some stuff. It's probably going to break, which is fine because I just want to see what it looks like. Oh, not code request. Python server, waiting for connection. Come over here, refresh that. Can't be reached, server broke, which is expected. So I'm printing this out over here, which is, yeah, split at the carriage return. I don't know if I want that. Yeah, that works, but yeah, I actually just want the time for right now. Yeah, I'm just gonna actually split it right there at a spaces. And then, yeah, that's just what I'm gonna do for right now. client connection. See, let's do this again. Refresh, broke. Here we go. So client coded text. I can do, where's the document? Host, look, I just want the URI. Yeah, I'm just gonna grab the URI for right now because that's all we really need for this. So client connection, URI colon request decoded request text at index 1, which corresponds to here. So there I can grab the URI like that. All right. So that makes, all right. I think that works. And then we're creating an instance variable called parse request, which is just the dictionary. So request, client request, and now we can send, so instead of the request URI, it's client request dot parsed request at URI. And I can do elsif or elif, because if I want to equals /time. Everything else should be working. So the client request, so grabbing client connection, I'm passing that entire connect to client connection into the request class, comes up here, passing it in with the request text, receiving it with a max size of 1024 bytes. I'm decoding it from bytes to actual readable characters. I'm splitting that string wherever there's a space, which returns an array of all the headers and everything, which is the parse request. I'm passing all that into the parse request, and comes in a decoded request. And now I'm literally just grabbing the value at the first index of that array which is the URI. And now I'm coming in here, client requests, accessing this instance variable, which is a dictionary with a key of URI. So if the URI is just a / then it comes in here, client connection.send HTTP response, encode, and it's encoding that. So let's see if this still works. All right, let's go to, hopefully nothing broke. Hello world still works, thankfully. Time still works. Let's see what else we can do. Can we optimize this more? Let's look at the documentation. Cool, request. All right, text body. Interesting. So after that's done, we can update our server with the new request. All right. I think is that everything? I think we can optimize this a little more. How about we pass in the URI into the build HTTP response and pass this if statement. Move this
on the build reply, all you have to do is pass in what exactly you want to have printed. Because if you look, the only thing that's different is the body in your HTML.
Right. So this is the only thing that's different, right?
So you'd pass in on the very first one, you'd pass in the date time. The other time you just pass in hello world, and then you substitute that in to your HTML as a F string.
Oh, yeah, I think I'm gonna. So if URI equals, I can build the HTML. And I can even just return this. Else URI equals time. And then just pass this stuff here and just return this F string, get rid of this. Current time, and I can even just, well, I'll keep that for right now. And so now I don't even, I can client connection dot send, build the HTTP response. Oh, no, pass in this client request into the response. It's pretty long, but that should still do everything that we want. See if it works. May have messed something up somewhere. I still have this, I can get rid of that now. All right, I'm gonna actually kill that, run it again. That still works. Oh no, what happened? Did I not have, do I actually need a, so something broke. Line 25 comes in here. None type object has no attribute encode. What am I looking at? Oh, do I need encode in here?
No, the value that it's trying to encode is being passed in from the dictionary.
Oh, I see what's going on.
So somewhere when we got the blank for the URI, we somehow put it as a blank data or a none.
So it's passing in. See if this works. There we go. So I just moved the encode to here. Let's see if it still works. Oh man. Line 25 again. It's the same thing. So what's going on, did you say? Hold on. Client request.
You're not returning anything from like line 19. Should be a return there.
Line 19?
Oh, never mind. I see the return now. Yeah, it's for whatever reason it's saying it's nothing. So when it's hitting the object time, so it's hitting line 15. It's doing something, and then it's returning a none type. So somewhere in here, it's receiving it as a none, or receiving it's hitting that logic board, but it's not processing it correctly.
URI parse. I wonder if it's something. I just want to see if it, because it worked the first time, or at least the time did. All right, time didn't work, but let's see if. Oh, crikeys. Oh. Let's see. All right, request. Just want to see if this works. Oh, did I not? Was I not invoking it? gonna be something really stupid. That one worked.
Yeah,
That one didn't
I'm
work.
not sure. That's the bit you need to encode. You got to, the entire response needs to be a client request. So the encode method has to be called on.
This part, wherever this gets returned.
What exactly is the URI printed out from the
Yeah,
request?
That's what I'm
Because
thinking.
does it have the slash in the front, or does it not have the slash?
Oh,
But even if it didn't have, because you weren't calling a slash earlier,
right.
so you're only calling it as just the local name dot port or :port. But then the other part was when it's hitting errors when you're actually trying to pass the time. So if you tried to call the localhost : port with just a blank slash, would that also cause an error? If it does, then the URI perhaps does not include the /. And so when you're trying to test it in your if cases, if, that might not be there.
Shows up there.
So for me,
go ahead.
I tried to, right after going on the request.py over there, just as a debugging purpose, you either debug it there or you do a print statement. Print what is actually URI that's being posted into the dictionary.
Yeah, it's
That
right
way,
here. This is that's what's coming
okay,
through.
so it is coming out. Okay.
Yeah. I know it's something stupid. Let's see. URI. What if I just did else? Doesn't make any sense. Ugh. I'm not going to keep you here the rest of the night because it's going to be something minute, I'm sure. So 1. All right. Okay, that's weird. It's this else statement. URI. That has something to do with it. Ugh. My connection, we have 2. Hello world. I have to go to \time. Something like right there. So I'm just going to use an else statement for right now. Time. There, finally, it's working. I'm not touching anything else. But that's weird that's happening. So interesting. And that's the end of HTTP. I'm going to stop recording for like past an hour, 10 minutes. Does anybody have any questions about it? So I guess I could have kept it here. I could have done this one, but I wanted to move everything in the build to HTTP response. I guess I probably should have just kept it here. This code, so, but I think this looks a little cleaner. But we will probably in the future, I think in number 2, we move this to like a router. Yep. Does anybody have any questions about HTTP server 1? No. Any questions about anything, JavaScript, HTML? Nothing? All right. Well, with that, I'll let everyone get back to it. If you haven't finished HTTP server 2 or still working on, the static web page or the to-do list, I'll let everyone get back to it. All right. I'll stay on for like another 15 minutes. If you have any more questions, feel free to Slack myself. If Noah's on, or Noah. Yep. All right.
Thanks, Tom.